The last wave phenomenon is interference, concept. If only a dipper vibrates, a series of circular wavefronts are propagating outward. In a ripple tank, a series of bright and dark circles will propagating outward. Consider points P, Q, R, T at different positions on the water wave. The displacement time graph for the water level at these points will be the same with the same amplitude, A. The displacement time graph for P and R will be the same with amplitude A. Also, the displacement time graph for points Q and T will be the same with amplitude A also. Simply speaking, particles P, Q, R, and T are vibrating with the same amplitude A. What happens if now we have two dippers vibrating together with the same frequency F and produce water waves of the same amplitude A? When dippers producing water wave in the same region with same frequency, which means that the wavelength of water waves generated by the dippers will be the same. Under these conditions, we say interference of wave occurs. Interference is a phenomenon due to the superpositions or adding of two or more waves together. When two dippers are vibrating with the same frequency and producing waves of the same amplitude, the circular wavefronts produced by each of the dippers will act together on the water surface as shown in the diagram, and a new wave pattern will be seen. Let S1 and S2 be the two dippers. There are two kinds of interference. The first one is constructive interference. At points X, Y, and Z, we have crest plus another crest. Therefore, we have a vector crest. In this case, we say constructive interference occurs at X, Y, and Z. At points D and E, we have the trough superposed with another trough, resulting a vector trough. Again, we say constructive interference occurs at D and E. However, at points F and G, we have the crest from S1 superposed with a trough from S2, therefore resulting low wave. And we say this kind of interference destructive interference. As a conclusion, at positions with crest plus crest or trough plus trough, we say constructive interference occurs. However, at positions with crest plus trough, we say destructive interference occurs. At positions of constructive interference, the particles vibrate with the maximum amplitude. However, at positions of destructive interference, the particles do not have any vibration. We will see the relation between interference and path difference. Consider two dippers S1 and S2 vibrating with the same frequency and producing water wave of the same amplitude. Let the dark circle represent position of crest, and let the gray circle represent the position of troughs. At point P, the crest produced by S1 and S2 adds together. Therefore, we have constructive interference at this point, and the path difference at point P is path difference equal to S1P minus S2P equal to 0. Points with similar effects as P is Q and R, where the path difference are the same, which is equal to 0. At the point Q, it is positions where the trough from S1 adds the trough from S2, which resulting a greater trough. Hence, is still constructive interference. At point Q, the path difference is equal to S1Q minus S2Q. Again, it is equal to 0. The point has similar effect as Q is S, where the path difference at S is also equal to 0. At point T, it is also crest plus crest, which means constructive interference occurs, and the path difference at point T is equal to S1T minus S2T, which is equal to 3 lambda minus 2 lambda, equal to 1 lambda. Points with similar effects as T is Y, which has path difference at Y equal to 1 lambda also. As a conclusion, at any point X, the condition for constructive interference occurs is path difference at X equal to S1X minus S2X equal to an integral multiple of the wavelength of the water wave, where n equal to 0, 1, 2, 3, so on. What happens at point F? At point F, it is the crest from S1 meets the trough from S2, resulting a destructive interference, and the path difference at point F equal to S2F minus S1F, which is equal to 2.5 lambda minus 2 lambda, equal to 0.5 lambda. Points with similar effects with F are G and H. As a conclusion, the conditions for destructive interference at any point Z is that the destructive interference occurs at the point Z when the path difference at Z equal to S1Ez minus S2Ez equal to 0.5 lambda, 1.5 lambda, 2.5 lambda, etc. In general, the path difference equal to n plus half lambda, where n is equal to 0, 1, 2, and so on. Let's look at the displacement time graph at positions of constructive and destructive interference. If the solid line represents position of crest and the dotted line represents positions of trough. At this instance, time 0, the red dots are positions with crest plus crest, that therefore they are at the position of constructive interference, and the displacement time graph will be for all the red dots. At this moment, the blue dots represent positions of trough plus trough. Again, it is constructive interference, and the displacement time graph for the position of the blue dots will be However, for the green dots, at this moment, they are at a position where the crest from one source add together with the trough from another source. Therefore, it is destructive interference. Hence, the displacement time graph will be a straight line with 0 displacement. What are anti-nodal lines and nodal lines? Consider two dippers S1, S2 vibrating with the same frequency and producing water wave with the same amplitude. Let the thick line represent crest and the thin line represent trough. Anti-nodal lines is a line drawing on the points with constructive interference with the same path difference equal to m lambda. The first one is of m equal to 0, the next two are m equal to 1, and the next two are m equal to 2. For nodal lines, it is a line joining all the points with destructive interference and of the same path difference again, equal to m lambda. The first two nodal lines are m equal to 0.5, the next two are m equal to 1.5, and the next two are m equal to 2.5. If the separation between the source S decreases, the separation between successive loops or anti-loops will decreases. Therefore, if separation between the source decreases, there will be more anti-nodal lines or more nodal lines. Also, if the wavelength of the water wave decrease, that means if the frequency of the water wave increase, the separations between successive anti-loops or successive loops will also decreases. Hence, there are more number of nodal lines or anti-nodal lines. So far, you have learned for sources vibrating in phase, the conditions for constructive interference is path difference equal to m lambda, and the condition for destructive interference is path difference equal to m plus half lambda. And the positions of anti-nodal lines A and positions of nodal lines N are as shown. If the source allows vibrating antiphase, then the condition for constructive interference and destructive interference will be interchanged. For constructive interference, path difference equal to m plus half lambda, while for disruptive interference, path difference equal to m lambda. So the positions of antinodal lines and nodal lines will be interchanged.